first section of problem 4. Determine the shear equation Px mx for the segment AB, and of course you want it from here to here. Okay, so what we're gonna do, we're gonna do a cut just before point B, which means that you're gonna get rid of the 10 kilonewton just before point B, and we're gonna draw a free body diagram, and this cut is as a function of x. Of course, the load is 2 kilonewton per meter, and there is a reaction here. AY is 30, that's given, 30 kilonewton, and the moment is counterclockwise, and it is 216 kilonewton meter. 216 kilonewton meters, 30 kilonewton, 2 kilonewton per meter, and x. Okay, so once we do the cut before point B, you will have a shear. I'm going to assume it up, so I'm going to call it Vx, and a moment, I'm going to call it x. So remember from the notes, if you have a load and you assume a shear up, so this will give you a shear the other side down, opposite to it in direction. This 2 shear will create a moment counterclockwise of this load. So this is a negative shear. If the shear is creating a counterclockwise moment, it's a negative shear. If it's creating a clockwise moment, then it is positive shear. Same thing if you have a load and you have a moment here, of course, a moment of the cut is going counterclockwise, and the other side it will be a moment clockwise, and this moment, these 2 moments will push the beam from up top, push it down, and this is a positive moment. If the moment will push the beam from down under up, then it is a negative moment. So these are sign convention. Go back to your PowerPoint presentation for the notes, and you'll find out these sign convention. So this shear is negative, and this moment is positive. This is from the sign convention. Let's go ahead and find out summation of forces at y to find out the shear. So summation of forces of y equal to 0. This would give you 30, and of course 2 times x is 2x, 30 minus 2x, and of course this is negative minus Vx equal to 0. So Vx, you take it the other side, it's minus 2x plus 30. This is the shear equation for the segment from AB. So for AB segment. Okay, let's go for the next one, moment. So if you do summation of moment equal to 0, this is negative, then it is, this moment is plus, this moment is plus mx, this one. And this force, 2x, will produce a positive moment. And of course, the distance, it is x over 2. Okay, and then you have this force, and that is, of course, it's going to give you a negative moment times x, the whole x, plus this. You can see that this is counterclockwise, so it's a plus moment. The whole thing is equal to 0, so 2 will cancel with 2. You'll end up with moment is equal to x minus x squared, because you take this one the other side, and you take this one, 30x minus 216. mx is equal to minus x squared plus 30x minus 216. This is very easy. This is for the segment AB. Okay, so this is very simple. So point A will be much easier than point B, but point B I will show it to you in the next few slides, and that's very easy. Just to find the shear and moment diagram from the area of the shear, and that's very easy. Thank you.